Okay, the last problem I'm going to do for you is in Mastering Chemistry. It's 11.104. This is a problem where you're using the ideal gas law. No, I'm sorry, not the ideal gas law. You're using stoichiometry. And, oh, no, I'm sorry, you are using the ideal gas law, but you're using stoichiometry. Any problems where the amount of something changes, the moles or the grams, you must use the ideal gas law, and sometimes you have to do stoichiometry. So this problem we're doing stoichiometry. And basically I haven't written the whole problem out because it was not useful, but it says when sensors in a car detect a collision, they collide, they cause the reaction of sodium azide, which is NaN3. That's a common name for sodium nitride, I guess, sodium azide, which generates nitrogen gas to fill the airbags within 0.03 seconds. And so that information, how fast it fills, is not really important because we're not being asked of anything of the rate of filling or anything like that. But it does say ask how many liters of nitrogen are produced at STP if the airbag contains 130 grams of sodium azide. Okay, so standard temperature and pressure, it's in your book. STP, standard temperature, is always 0 degrees Celsius and 1 atmosphere. So STP is always 0 degrees Celsius and 1 atmosphere. Okay, so they give you 130 grams of this material. But they want to know how many liters of this material, of the sodium, of the nitrogen. And so if you have grams of one thing to get to liters of another, you're going to have to use the stoichiometry. And so the first thing we do with stoichiometry, if you remember, we convert this to moles. So the molar mass, so 1 sodium and 3 nitrogen added to 65 grams of this material per 1 mole will give me exactly 2 moles of sodium nitride. Okay, so you know you're going to get, if you just look at the equation, you know because you've got 2 moles given, and the stoichiometry requires 2 here, you're going to get 3 moles of that. But we'll go ahead and do it the way you do your stoichiometry. What's given 2 moles of NaN3 is what's given. My balance, the chemical equation say I have 3 moles of N2 per 2 moles of NaN3. I put that on the bottom because I want to cancel out. And so I'm given the fact that I have 3 moles of N2. So that's how much is going to be produced. Now, in order to get that at standard temperature and pressure, those moles, then I have to use the ideal gas law. So I'll go ahead and continue here. PV equals nRT. My standard pressure is 1 atmosphere. My volume is what I'm looking for. I don't know it. That's what the question is. What's the volume? My moles is 3. My gas constant is 0.0821, and remember that's liter, atmosphere, Kelvin, and mole, meaning the volume that I get will be in liters. This pressure must be in atmospheres, which I said standard temperature and pressure is 1 atmosphere. My temperature is going to have to be in Kelvin, so 0 degrees Celsius plus 273 is 273 Kelvin. So basically, this is 1, so I don't have to do anything to that. And so 3 times 0.0821 times 273 is 67.3 liters. Okay, let's go over this problem again. It's written up here in case you didn't get something. Okay, it gives you a certain amount of a material that's in a balanced equation, 130 grams of this. They want to know how many liters of this are going to be produced at standard temperature and pressure. So evidently, this reaction is taking place in a container that can expand to a certain volume at certain temperature, 0 degrees Celsius, and a pressure 1 atmosphere. Okay, so to figure out how many moles, you got to figure out how many moles of this and do stoichiometry. I calculate the molar mass of sodium nitride, or sodium azide, the common name. 130 divided by that molar mass is 2 moles. So actually that 130 grams is 2 moles of material. The 2 moles of material, stoichiometrically, based on the balanced equation, is 3 moles of this for every 2 moles of that. So I put the 2 moles of sodium azide on the bottom so that they can cancel out. The 2's cancel out. 2 times 3 divided by 2 is 3. So it's going to give me 3 moles of material. With those 3 moles, what will they occupy? These moles of gas. So I use the ideal gas law. Glare there. PV equals nRT. The standard pressure is 1 atmosphere. The volume is what I'm looking for. I have 3 moles of material. My gas constant is 0.0821. And my temperature is 0 degrees Celsius, but you add 273 because you must use Kelvin with the ideal gas law and all gas laws. And so that's 273. So 1 times V is just V. I don't have to do any division here. And 3 times 0.0821 times 273 is 67.3. And because my gas constant has liters in it, this has to be liters. I hope this has helped some of you. If you have further questions, please let me know.